Hey there, we're going to do a small matrix algebra review. Now the important thing to remember is you will not be doing this by hand. The computer is going to be doing everything, but I want you to know what's going on underneath. Okay? So let's start small and work our way up. Let's look at a 2 by 2 matrix. We're going to be looking at a lot of these. So we have A11, A12, A21, A22. 2 rows, 2 columns. All right, and when we refer to these, you always refer to a matrix as an R by C, the number of rows times the number of columns. Okay, so I would say this is a 2 by 2. And if I had another one, I could say something like this. Now this baby would be a 3 by 2 because it has 3 rows and 2 columns. Okay, does that make sense? Good. All right, so what are some things that we do? We add, and it has to be the same size. So if I have 2, 1, 0, 4, plus 5, 9, 3, 6, then the output is going to be 7, 10, 3, also 10. That was a fluke, by the way. So the output will be the same size. It will still be a 2 by 2. And you can subtract. Again, when you add, it's just going to be, you'll have A plus B equals C, and you just add each element in the matrix. If you have A minus B equals C, you just subtract every element in the matrix, and that's nice. Okay? Another thing that you do a lot is do the transpose, and depending on what you do, there's a lot of notations. You can have A prime, A T, they all mean the same thing. So what you're doing is you're turning that which was rows into columns, that which is columns into rows. So let's say I have my original A matrix, was 3, 2, 5, 1, 6, 8, and A transpose is going to be 3, 2, 5, 1, 6, 8. And we're going to be using a lot of those in what we do. Okay? But again, not to worry, the computer's going to be doing a lot of these, but I just want you to see that's what's going on. Okay? So transpose, we do those a lot. And then, now the worst thing to do is do the matrix inverse. So you can't just do, take a matrix and divide everything by 1 over itself. That doesn't work. In the case of so this gets very complicated very quickly. Complicated. Okay. In the case of the 2 by 2, there's actually a simple way, and I'll show you how to do that right now. There's something that we can make that's called the determinant, and that's true in every case. Determinant, but the 2 by 2 has a very simple way to do this. Determinant. Okay, so for the 2 by 2, it is very beautiful. It is A11 times A22 minus A12 times A21. Okay? And if that is non-zero, then we have a matrix inverse. All right. Then to get the inverse, you're going to have 1 over the determinant times A22, A11, and you'll reverse the signs on the off diagonals. Okay, doesn't this look like fun? All right, let's give one a test. Want to? No? Good. All right, let's try it out on the next slide. This is my favorite one. 1, 2, 3, 4. Okay, so the determinant, okay, these are like absolute value bars. It's going to be 1 times 4 minus 2 times 3, and that's going to be 4 minus 6 or minus 2. Okay, so our determinant is minus 2. Now, even though that looks like absolute value bars, it is not absolute value. You just take what you get and leave it, okay? Now, to get the inverse, we're going to have 1 over minus 2. Okay, we'll flip over the 4 and the 1, because you flip over the diagonal elements, and then you change the off diagonal elements. Oh, my fault, you change the sign. And let's see what we have. So we have 4 times minus negative 1/2. So that's going to be minus 2. And minus 2 times minus 1/2 gives me 1. And minus 3 times minus 1/2 gives me positive 3/2. And 1 times minus 1/2 gives me minus 1/2. Okay. So that's my alleged inverse. So how do I know if I'm telling you the truth? And you should be saying about now, how do I know if you're telling me the truth? All right, so the way to tell, I should take the original matrix, multiply by the inverse, and that should give me what's called the identity matrix. All right, let's change the slide. The identity has ones on the diagonals and zeros every place else. Okay, so let's see. Oop. So I had 1, 2, 3, 4 times, see if I can remember this, hang on for a second. Okay, I still don't have it. 2, 1, 3 halves minus 1 half. I think this is it. And let's see if it works. So you'll get to see a little matrix multiplication. So it'll be 1 times minus 2 plus 2 times 3 halves, and then 1 times 1 plus 2 times minus 1 half. We'll clean it up in a minute. Then 3 times minus 2 plus 4 times 3 halves, and then 3 times 1 plus 4 times minus 1 half. Okay. That should be 3 halves. Sorry. Okay, minus 2 plus 3, and this one is 1 minus 1, and this is minus 6 plus 6, and this one is 3 minus 2. And then I dance with joy because I have 1, 0, 0, 1. Okay? And that's as it should be. So I know I got the right answer. Okay? So what we're going to be doing, or at least what is going to be going on, is we're going to have vector matrix multiplication, and we're going to have, that's a V, we're going to have the 1 vector, the 1 prime vector, times a covariance matrix times 1 again, and have a set like this. Okay? We'll take that whole thing and get its inverse. All right? And that's one of the things we're going to be doing. And we're going to be doing some, let's see. Sorry. Prime. So you'll have the 1s, the covariance, and this time the Z. That's the actual observations. And put that together. That's your prime. Okay? And that's as it should be. And this is going to give us a critical piece in what we're doing. But those little puzzle pieces that I gave you so far are just ways to start to think about how things are going. Okay? Hope this helps.